Think about the last time you touched something frozen. Ice, metal in winter, a chilled drink. You recoiled. You felt the bite. Your fingers tingled. Cold is real, right? A simple sensation. A clear experience. But here's the thing. Cold, as we imagine it, does not exist. Not in the way we think. It is not a substance. You cannot bottle it. You cannot pour it into a glass. Cold is the absence of heat, that's all. Simple enough, right? But it gets stranger. Heat is energy. Energy is motion. Every atom, every molecule vibrates, dances, moves. Faster means hotter. Slower means cooler. Stop moving? That would be absolute zero. But nothing ever truly stops. Not even in the deepest reaches of space. Not even in the most controlled labs. Motion is the essence of the universe. Stop and think about what this means. What we call cold is simply less motion, less energy, a deficit. We measure it against the baseline of atomic vibration, so when your hand touches ice, it is not that the ice has something called cold inside it. Your hand is giving up energy. Heat flows from you into the ice. Your neurons interpret that energy loss as cold. That alone flips the idea upside down. Cold is not transferred. It is your own energy leaving you, your warmth escaping. Now things get strange. Consider outer space. Vast, dark, seemingly empty, temperatures of a few degrees above absolute zero. Almost nothing. Cold? Yes, in a manner of speaking. But those regions are filled with radiation, cosmic background energy, photons streaming, atoms barely vibrating. There is no place without motion, no place truly cold. Think about that for a moment. Absolute zero Kelvin is the limit where atomic motion ceases, but quantum mechanics refuses to allow complete stillness. Even at 0 Kelvin, atoms jitter. 0-point energy, a faint, relentless hum of existence. Cold can never be absolute. It is always relative. It is always measured against motion, always measured against energy. Here's the thing. Temperature is not a thing that exists independently. It is a statistical property, a measurement of the average motion of countless particles. When we say it is 0 degrees, we are not describing a substance called cold. We are describing the speed of atoms, not slow, not fast, just a number in a spectrum of motion. Think about your refrigerator. You open it. You feel the chill. That chill is simply a region where molecules move slower than in your room. You interpret it as cold because energy leaves your body. Energy flows from high to low. That is the law of physics. Cold is simply the direction of energy transfer. Same pattern, same physics. Ice cubes melt in your hand. Your hand loses heat. Ice gains it. At the molecular level, the vibrations increase. Energy is redistributed. The sensation of cold disappears. It never existed as an entity of its own. And yet our brains insist on naming it, treating it like a presence, a force, a thing to fight against. Winter jackets, heaters, blankets. We respond to cold as if it were tangible. But it is only a measure of what we are losing, not what is there. Stop and think about what this means. Cold is entirely relational. It has no independent existence. It is meaningful only when compared to something warmer. It is a concept defined by heat. It is absence, not presence, empty, yet powerful in our perception. Now imagine pushing this further. Deep space, the edge of a black hole. Temperatures approach near zero. Atomic motion slows, but 0-point energy hums. Even there, absolute stillness is forbidden. The universe will not let matter cease its dance. Energy persists. Motion persists. Cold, as an absolute state, cannot exist. And yet every day we experience it. We call it cold. We shiver. We build fires. We feel the bite of ice. Our perception is valid, but the underlying truth defies intuition. Cold is never a thing. It is always absence. Always relative. Always motion reframed in reverse. That is the paradox. Simple, observable experience versus the hidden mechanics of the cosmos. And this is just the beginning. Because once we grasp that cold does not exist, the implications for thermodynamics, quantum mechanics, and even cosmology start to unfold. Energy, motion, and temperature become more than abstract concepts. They become the fundamental language of reality. And that raises a question even more profound. If cold is just absence of motion, what does that tell us about the universe, its energy, and the very nature of existence itself? The answer will challenge everything you thought you knew about temperature, matter, and the invisible dance of atoms. Let us begin with a simple observation. When you pour water into a cup and place it in the freezer, it eventually solidifies. Ice forms. The liquid becomes rigid. You feel cold when you touch it. Simple enough, right? But here's the thing. The water isn't generating cold. It is losing heat. Its molecules are slowing down. Motion decreases. That is the process. Think about a crowded dance floor. Everyone is moving frantically. That is a hot liquid. The dancers are energetic, colliding, bouncing. Now, one by one, they slow down. They shuffle in place. Eventually, movement is minimal. That is like freezing. But no dancer disappears. Motion persists, just at lower intensity. Cold is simply the perception of less motion. Now, let's consider the concept of temperature. Temperature is a statistical measure. It is the average kinetic energy of countless particles. Faster movement equals higher temperature. Slower movement equals lower temperature. Stop and think about that for a moment. There is no independent coldness, only a scale of motion, only energy in disguise. Here's the thing, our senses are tuned to this relative motion. Place your hand on a metal spoon at room temperature. You feel a chill. Why? Because metals conduct heat efficiently. Your hand loses energy to the spoon. Cold is the sensation of that energy transfer. Energy leaving you, not something the spoon contains intrinsically. Stop and think about what this means. Every cold experience is defined by contrast. The room is warmer than the ice. Your body is warmer than the metal. That gradient drives the flow of energy. Without contrast, the concept of cold vanishes. Absolute uniformity would be invisible to us. Cold requires heat to exist, not as a substance, but as a relational property. Now things get strange. Consider the universe, vast cosmic voids with temperatures near absolute zero. Molecules hardly move. Does cold exist there? Not really. Quantum mechanics ensures that motion never stops entirely. Zero-point energy persists. Even in the emptiest space, atoms jitter, vibrate, and fluctuate. Cold can never reach absolute stillness. It is a limit, not a state. Same pattern, same physics. Every lab on Earth that approaches near zero Kelvin experiences the same limitation. We can cool atoms to fractions of a Kelvin above absolute zero. Superfluids appear. Matter behaves strangely, but even then, residual motion remains. Entropy cannot vanish entirely. Energy is never zero. Motion persists in subtle quantum forms. Cold is always defined by what it is not, the absence of energy flow. Think about heat transfer in everyday life. A hot cup of coffee cools over time. A cold drink warms. Energy redistributes until thermal equilibrium. The perception of cold or hot fades. Temperature is not static. It is the result of energy redistribution. The cold cup never contained an independent substance called cold. The warmth of your hand simply flows into it until balance is achieved. Here's the thing. Even in extreme refrigeration, in cryogenics, or deep space laboratories, cold is always relative. Thermodynamic laws govern the flow of energy. Heat moves from higher to lower energy. Cold emerges as a relational experience, never as an absolute property. That subtle distinction is crucial. It shifts our understanding from substances to processes, from perception to physics. Stop and think about what this means. When we speak of freezing, chilling, or sub-zero conditions, we are not describing a unique material. We are describing motion, degrees of vibration, energy exchanges, and quantum effects ensure that motion never completely ceases. Cold is a descriptor, a measure of deficit, an absence that only exists because energy is present somewhere else. Now let's take it further. Imagine a region in space near a black hole. Atoms are sparse. Temperature approaches zero. Motion slows dramatically, yet quantum fluctuations ripple through space-time. Particles appear and vanish. Zero-point energy persists. Absolute cold cannot exist. What we interpret as extreme cold is merely an energy scale, a range of molecular activity that approaches but never reaches true stillness. And here's the most remarkable part. This perspective connects directly to entropy, the arrow of time, and even the behavior of matter at cosmic scales. Cold is not just a laboratory curiosity. It is a window into the fundamental mechanics of the universe. Motion, energy, and fluctuation form the backbone of reality. What we perceive as cold is just a shadow of that deeper truth. Think about that for a moment. Everything we call cold, every frozen lake, every winter morning, every cosmic void, is a relative measure. It is a consequence of energy elsewhere. It is motion reinterpreted. And understanding this flips our intuition. The universe is never truly static. Silence and stillness are illusions. Motion persists, even where we think there is nothing. And that realization opens the door to questions even more profound. How does energy distribution shape the cosmos? How does motion define matter itself? How does the absence of motion, what we call cold, connect to the fundamental structure of reality? Once we explore that, the boundaries between hot-cold energy and existence begin to dissolve. It is here that physics begins to reveal its most astonishing lessons. Let us explore this further. Energy and motion are inseparable. Temperature is just a reflection of that connection. Every molecule vibrates, every atom dances. Even in solids, where motion seems frozen, atoms oscillate around equilibrium positions. Stop and think about that for a moment. Cold is never stillness. It is motion slowed, it is energy restrained. Now imagine a gas in a sealed container. The molecules collide endlessly. We measure temperature as the average kinetic energy. If we cool it, the collisions slow, the molecules lose speed, but no molecule ever truly stops. Quantum mechanics forbids absolute stillness. Zero-point energy remains. Motion persists, hidden beneath our macroscopic view. Here's the thing. When we approach extremely low temperatures, matter begins to behave strangely. Bose-Einstein condensates appear. Atoms occupy the same quantum state. Macroscopic quantum phenomena emerge. Cold at this scale is surreal. It is not the absence of motion. It is motion unified, collective, coherent, yet still there, still vibrating in a subtle quantum rhythm. Think about that for a moment. Even when matter seems motionless, the universe hums. The vacuum itself is alive with fluctuations. Virtual particles blink in and out of existence. Energy pervades the emptiest space. Cold, in its classical sense, cannot exist there. What we perceive as near-zero temperatures is a carefully measured average. Underneath, the quantum sea never rests. Let us return to everyday experience. When you touch ice, your body loses energy. Heat flows from your hand into the ice. That energy redistribution is what produces the sensation of cold. But the ice does not contain cold. It is simply a region of lower kinetic energy relative to your hand. Perception arises from difference, not substance. Now things get strange. Consider the cosmic microwave background. It is roughly 2.7 Kelvin. That is cold, unimaginably cold by human standards. Yet that temperature corresponds to a persistent energy field. Photons constantly zip through space. Matter interacts occasionally. Motion exists even at this lowest detectable energy scale. Absolute zero remains unreachable. The universe forbids it. Stop and think about what this means. Cold is fundamentally relational. It depends on contrast, difference, and motion elsewhere. There is no standalone cold. It is defined by the presence of heat, by the deficit of energy, by the relative speed of atoms. It is absence turned into perception. Energy leaving you, energy moving elsewhere. That is all. Here's the thing. The deeper we probe, the more cold dissolves as a concept. In quantum thermodynamics, even 0 Kelvin contains irreducible fluctuations. The Heisenberg uncertainty principle prevents complete stillness. Position and momentum cannot both vanish. Motion is guaranteed. Energy is guaranteed. Cold is a shadow, a story we tell about what we lack, not what exists. Think about liquids near absolute zero. Superfluids glide without viscosity. Matter behaves collectively. The underlying atomic motion does not disappear. It becomes coherent. Temperature remains a measure of residual fluctuations. Cold is not eliminated. It is transformed. A different rhythm emerges. Same pattern, same physics. Everywhere we look, the universe refuses true cold. In labs, in cosmic voids, in the quantum vacuum, motion persists. Energy flows, redistributes, vibrates, and oscillates. Cold is a human-scale abstraction, a sensation arising from relative motion and energy transfer. It is a tool to describe a deficit, not a substance in its own right. Now consider the implications. Entropy, the arrow of time, thermodynamics, they all hinge on energy and motion. Cold as absence is intimately connected to the flow of heat. Heat flows, systems equilibrate, order evolves into disorder. Cold does not drive processes, heat does. Cold is simply the perception of what heat has left behind. Stop and think about what this means. Every frozen landscape, every icy lake, every deep space void is a canvas of relative motion. The vibrations of atoms, the jitter of quantum fields, the ceaseless motion of particles, all persist beneath the illusion of stillness. The universe never sleeps. It never halts. Cold is never absolute. And that realization brings us closer to a mind-blowing truth. What we call cold is inseparable from the energy it lacks. Energy defines reality. Motion defines matter. Absence is only meaningful in relation to presence. Cold is a concept, not a state. Which means when we say freeze, chill, or ice, we are really describing motion restrained, energy redirected, and the hidden dance of atoms playing out beneath perception. And once you see that, the universe itself begins to feel less solid, less static, and far more alive with subtle motion than anything your senses could detect. Now we reach the deepest layer of understanding. Cold is not a substance, it is absence, a deficit, a lack of energy relative to something else. But absence, by itself, has no independent reality. It is meaningful only in context, only in relation to motion, to energy, to the ceaseless dance of particles. Think about the universe at its grandest scales. Galaxies, nebulae, interstellar voids, temperatures approach absolute zero. Molecules barely move. But even in that extreme, zero-point energy persists. Quantum fluctuations ripple through space-time. The vacuum is never empty. The cosmos hums with hidden activity. Cold as absolute stillness cannot exist. Here's the thing. This insight reshapes how we understand reality. Energy is the fundamental currency. Motion is the fabric of existence. What we perceive as cold is not an entity, not a thing that can be trapped or contained. It is a measure of motion elsewhere, a story our senses tell about energy leaving us. The universe operates not in absolutes, but in relations. Stop and think about what this means. When we freeze water, we perceive cold. When we touch ice, we shiver. When astronomers measure the cosmic microwave background, they declare it cold. But in every case, the sensation, the measurement, the label exists because motion exists elsewhere. Without energy and motion, cold would vanish. It would be meaningless. It is a relational shadow cast by the presence of energy. Now things get strange. Consider the flow of time. Entropy measures disorder. Heat flows. Motion persists. Cold is the direction of energy flow. It is a guidepost for change. The concept of temperature, hot and cold, emerges from the statistical mechanics of countless particles. We navigate the world through differences, contrasts, gradients. Without heat, cold is invisible. Without energy, absence has no meaning. The beautiful part is how this idea connects to the deepest questions of physics. Energy conservation, thermodynamics, quantum mechanics, cosmology, they all converge here. Cold, understood correctly, is a bridge between human perception and universal law. It shows that reality is relational, not absolute, that absence is always defined by presence, that the universe never rests. Think about a superfluid, near absolute zero. Atoms lose individual motion but move collectively. Energy does not vanish. Cold does not dominate. Motion persists in new forms. What appears as stillness is actually coherent activity. The universe is always alive with subtle vibration, hidden beneath our perception. Same pattern, same physics. Consider the edge of a black hole. Temperature drops near absolute zero for infalling matter, yet quantum fluctuations remain. Motion, energy, and uncertainty persist. Cold cannot exist in isolation. It is defined by what it is not: the energy of the surrounding environment, the ceaseless dance of particles, the subtle hum of the vacuum. Stop and think about what this means. Our intuition about cold is a human-scale approximation. It is a survival tool. It alerts us to heat loss, danger, or discomfort. But in the grand tapestry of the universe, cold is a concept, not a state. It is the absence of motion. It is relative. It is always shadowed by the presence of energy. Here's the thing. Everything we experience as cold, from winter mornings to frozen lakes, from cryogenic experiments to the void between stars, is defined by contrast. It is a reflection of energy elsewhere, a mirror of motion restrained. The universe never stops, motion never ceases, energy never disappears. Cold is a story we tell about what is missing, not what exists. And that leads to a profound realization. Reality is built on motion, on energy, on ceaseless activity at every scale, from vibrating atoms to quantum fluctuations in the void. The absence of motion is never absolute. Cold, as we perceive it, is a fleeting shadow cast by energy flowing elsewhere. It is a lens through which we interpret motion, not a tangible thing itself. Think about that for a moment. The universe never truly rests. Stillness is an illusion. Silence is never absolute. Cold is a human interpretation of absence, a relational property born from energy's presence. Everything is alive with subtle motion. Every particle dances. Every atom hums. Every vacuum fluctuates. And that is the final astonishing truth. Cold does not exist. It never has. It is absence framed by presence. It is the shadow of motion, the echo of energy. It is a concept, not a substance. The universe is always in motion, and so cold is nothing but a story we tell about the infinite, dancing cosmos.